In effect, there are many more distress types. What we have here is a list. It's still a partial list. There are several of those. There are many of those. Delamination or slippage. This is something that happens when asphalt overlays an old asphalt and there's not a good bond between the two layers. And so horizontal loads can promote the tearing of the overlay. In this picture here, you see it's a post box where the post vehicles stop and accelerate to deliver a post or to take letters. As you can see here, this moon-like shaped cracks appear, and the white below the black is actually the old asphalt surface, or maybe an old Portland cement concrete surface that was exposed. This is very common in areas of braking and accelerating, in combination, of course, of bad bond between the layers. Aggregate polishing is the case where extra many years of usage polish the aggregates, the surface aggregates, and they make the skid resistance unsafe. Potholes, this is something that is very common, where a piece of the asphalt concrete dislodged and was washed away or broken away. Now, a patch is our way to fix potholes, but in fact, when we think about the pavement distress, a patch in itself is a distress. One reason is that it's very hard to make a patch that is flush with the surrounding surface, and therefore there's always some unevenness built into the pavement after patching. The second point is that the skid resistance is not uniform, so if you have a very long patch and it is only of partial width, then if there's a braking event, the tires on the patch would experience different friction as compared to the tires running on the existing road. Raveling and stripping, these are two distresses that I leave up to you to read about. Now, mechanical damage is where there's something falling on the asphalt and leaving marks. Let's say if you have a crane and it lowers its supports and they dig into the asphalt, then they leave some impression. This is called mechanical damage. Another option is if something falls from a truck and is dragged behind, then you have mechanical damage at the surface. Others here, you can see their names. Upheaval, if you have a local unevenness that results from the pavement moving upwards. Local depression is where you have a local drop in the elevation. And total collapse. These two pictures show the case where the load far exceeds the bearing capacity of the pavement, and this is a total collapse due to some weather-related event like flooding. Now, the quantification of distress is commonly done by performing condition surveys and rating the damages, the observed damages at the surface. And one of these techniques is called the PCI. This stands for Pavement Condition Index. And the PCI is a method that was originally developed in the 1970s for the US Department of Defense. The idea is to be able to rate a pavement from 0 to 100 or from fail to good. You can see here the ranking procedure, the ranking scale. And there are actually two procedures. One is for airports, and the procedure is summarized in ASTM D5340. And there are 16 damage types that are defined in this procedure. And then there's another procedure for roads and parking lots, ASTM D6433, where there's 19 different damage types. Now, the PCI system principles are summarized in the ASTM standards. And I will just talk about the general procedure. This is, it's not for engineers, but engineers use this information afterwards to make decisions. So the actual procedure of the PCI system is based on the following idea. First, the network is divided into branches and sections and units, and these units are surveyed. In general terms, each unit is associated with a deduct value. So we can imagine that the pavement starts with a grade of 100 out of 100, and then we deduce points based on distress that is observed. And the type of distress, the severity, and the quantity define the deduct value. Now, the PCI of any sampled unit, we according to the procedure, we don't have to sample all the units in our pavement system. But for a given sample unit, what we do is we take 100 and we remove from that the maximum CDV, which means the sum of all the deduct values that are less than 5 except for 1. So the maximum CDV is then removed from or subtracted from 100, and then we get the pavement condition index of that unit. The problem is that if we have more damages, many damages, more severe damages that deserve a deduct value of more than 5 points, then there's a procedure to ensure that we are not reducing the pavement condition index to a negative value. So this is mostly what the standard is all about, is to ensure that the deduction from 100 is done in a consistent way that takes into account the different deduct values that are larger than 5. And this is why it says here we need a correction. So if none or only one of the deduct values is greater than 5, then the procedure is rather simple, and else we need some correction. Now the corrections are of course needed to ensure that there are no double deductions, because there are many damages that occur in the same area, like we saw before when there's rutting and alligator cracks in the same location. So for airports, a pavement branch can be runway, taxiway, or some apron. And then for a section, we can think of some uniform construction, or something with the uniform usage history. So if we are thinking about a runway and maybe there was a repair along the runway somewhere, and this now has a different construction as compared to the other runway pieces, then this in itself is a different section. Another way to look at this, if we have a runway and the runway center is loaded more than the runway shoulders, so this is the center area or center strip of the runway, then this center strip should be considered as a different section as compared to the shoulders, because of the fact that the usage history is much different, even though they have the same construction. And lastly is a pavement unit. That is when we subdivide the pavement section for the purpose of visual inspection. So for visual inspection purposes, in order to to calculate the PCI, we need to visually evaluate the damages or the distress in a section. And since we don't, at least when the standards were published, it was not possible to fully evaluate visually the full area of a section, then we were splitting the sections into smaller units and then evaluating some of the units. So the pavement unit, according to the PCI standard, is some subdivision of the pavement section that was defined here into smaller areas for visual inspection. This is an example of how PCI survey is used for decision making. This is an airport, and the different elements or branches in the airport are being shown here with different colors. So here we have a runway, here we have a parallel taxiway, we have some transverse taxiways, and we have some parking areas for airplanes. And the color coding here, although it's not based on the standard terminology, it's just to show you that certain areas are green and certain areas are black, where green indicates excellent condition and black indicates failed condition. And also the runway here, we can see that the runway is in very poor condition, and it is also split into the central area and the shoulder area, where the central area carries most of the loads, and the shoulders, they are usually carrying very light loads, if at all. And here we have the runway heads that are in fair condition, and so forth. So if we have a given pot of money and we need to decide where to use the money, then this image is a good decision making tool, because we can see the condition, we can see the location, and we can also decide that something is not important for the operation of the airport and we don't want to spend money on it, so we can also prioritize the locations. This is just one decision support to pavement management. So pavement managers are using a lot of condition surveys, and PCI is one of them. Very, very common. So let's look at the usefulness of a PCI, of the PCI concept for pavement evaluation. So we have a graph here that shows time, could be in years or months, and here we have a PCI of a pavement section or a pavement branch or an entire pavement system. So when it is new, we start with a very good grade of 100%, and then over time there is a deterioration of the system. And then at some point, if there was a decision to make a repair, we have an increase in the PCI, and then we start a new deterioration cycle. So some interesting things to see here. First, the level at which we would like the pavement to be repaired at is a decision. We can make a decision in terms of a pavement management decision that whenever the pavement condition index drops below a certain threshold value, we have to repair. So this can be chosen to be here. It could also be chosen to be here. Secondly, after repair, we can observe the deterioration curve over time and check if the repair was done in high quality. If the deterioration curve is faster after the repair, that means the repair was not was not done in a good way. And we have this prolonged deterioration afterwards. That means that we really targeted in the repair the causes of the problem. We can also assess design methods, because if two new pavements designs, one of them is deteriorating faster than the other, it means that there was something wrong with the design or with the construction. The shape of the curve could also mean something to indicate the quality of the materials and the quality of the construction. And of course, we can also check the amount of money that was required to increase the PCI value, and check over a very long period of time if the strategy for maintaining the pavements here is more cost effective as compared to, for example, maintaining the pavements. So let's say we have a PCI versus time, and we have two maintenance strategies. We start with 100%, and then one case deteriorates to a low value, let's say 40, before it is repaired. And the other case is where we set the lower threshold to 80 and then repair. Of course, there's more repairs in this maintenance strategy, but the cost of which is much lower as compared to this full reconstruction that may be needed if we allow the pavements to deteriorate that low. And so there is a tool here to look at the funding and to look at the technology, and all comes from obtaining a PCI over time. So I really drew continuous lines, but in fact the surveying intervals are not continuous. We have today the technology is giving us points along this curve.